So today we are talking about the technical approach to cheese troubleshooting. We're going to talk about the technical approach to cheese troubleshooting, and it's about what are the different methods that we need to consider in order to be able to understand and fix the eventual problem that we may find during the cheese making process. Oops. So the cheese defects can be classified into two major categories. The first one is defects from microbes development. So most of those defects will be the consequence of microbiological development of either bacteria, yeast, or molds, either inside the cheese, as you can see on the top left picture with the development of Butyrex bacteria, or the middle one with a development of Pseudomonas family on the surface of the cheese, or the white with the fluffy, hairy gray molds with contaminated with mucor, which is a mold. And the second family of problems is more linked to technological defects. The composition of the cheese is not correct. The way that the cheese was made was not correct. It can be in terms of temperature, in terms of speed, in terms of acidification profile. So we can see slits in here, some cracks in the paste of the cheese. We can see some discoloration defects in the cheese, or we can have some texture problem in the cheese. This is mainly due to the way the cheese was made. But those two defects most of the time are linked in a way that the development of yeast, molds, or bacteria that are undesired will be the consequence of compositional problems. So if you make some, I can say mistakes during the cheese making process, having too many moisture, too high moisture in the cheese, too much residual sugars, too low of a pH at unmolding, and so on. All those parameters that will be different, that will move from your normal values, will trigger the development of microbes. So you have to consider that those microbes, particularly the black molds, coliform, Pseudomonas, all those families of bacteria, they are somewhere in your environment. They just want you to do one thing, a mistake in your cheese making process. So then when you have a problem, they know that the composition of the cheese will be good for them, the atmosphere, the environment will be good for them, and then they will be able to multiply. So in any case, when we have this kind of microbiological problem, we need to consider three different aspects. The first one is the contamination of the milk or the cheese with the bacteria, yeast, or molds. Where does it come from? What is the initial source of the contamination? But after the contamination, this microbe needs to be able to multiply, to be able to create the problem on the cheese or in the milk, and then it needs to survive. I can take the extreme example of Listeria. Listeria will come from somewhere, either the external environment, it can be the milk, it can be the workers, it can be the boots. Then this Listeria eventually will multiply in the cheese if we have the moisture, the pH, the temperature that is in favor of Listeria development. And then this Listeria needs to survive in the cheese in order to be able to create a problem. If the Listeria disappear, it's not a problem anymore. So the problem disappears on itself. So we need to concentrate if we want to fix this kind of problem. Concentrate on those three different factors. Contamination. This one is fixed by the classic hygiene, by cleaning the environment, the surface, the cheese making equipment. Eventually, the hygiene of the primary material by pasteurizing the milk. And we need after to fix the multiplication and then the survival ability of those bugs. Those two parameters will be fixed by the technological hygiene. The technological hygiene will be the control of all the cheese making parameters like pH, time, quantity of starter culture, temperature profile, aging temperature, all those parameters that will create hurdles for the microbes development. So the more hurdles you can control and install over the cheese making process, the more control you will have. So do not forget that the classic hygiene, spending your time in brushing the floor every day, drinking a glass of chlorine and so on, will fix everything. This fix only the contamination point. But if this fail, if you do not focus on the multiplication and the survival ability, which is controlled by the technology, if you do not control what you do, in this case, you will have the problem. So technological hygiene in food industry, we tend to focus on personal hygiene, clothes, jewelries, hand washing, hairnets, and so on, equipment, the facility, the workshop and the cheese making, the floor, the walls, the surface, the doors, and all of that. The raw material with the quality of the milk, salt, starters, rennet, and with often the idea of high quality milk is a low total bacteria count milk, which is absolutely not true in artisan cheese making industry, because we need to consider the quality as well of microbes. It's not about just the quantity, but we need to focus also on the behavior. We can have a perfectly dressed worker with the right boots, with the right equipment, with all the air nets and everything, with a beard net. And if this cheesemaker has to go outside to collect, I don't know, packaging, storage, papers, and so on that are stored in additional storage that is outside without changing clothes, in this case, all this personal hygiene disappear because we bring the external stuff like listeria, why not, inside the cheesemaking facility. So the behavior of the cheesemaker is very, very important. And then the technological hygiene as well. We need to understand what are. So we need to spend much more time in recording, tracking, measuring important parameters in order to avoid the multiplication of bacteria in the milk and cheese. So we'll talk a little bit about acidification profile, temperature, water activity, salt, and so on. But the most important is to have time to talk about the final questions at the end of the slideshow. So when you have defects of microbiological origin, we need to clearly identify the microbe involved, either by microbiological test or by fungi identification. The more picture, description, smell, taste, eventually, aspect, when it develops, all those parameters that you can give will permit to have a better identification of the microbes. The worst is to have a wrong identification that will lead to a different adjustment during the cheese making process. And it can become worse because you did not identify properly, so you did not install proper change. Then we need to find the initial source of contamination. When we know what kind of bug it is, we need to find out where it comes from. We can eventually start to understand if it comes more from a human or a mammal contaminations, like the coliforms or salmonella will be more humans or mammals or milk contamination, while pseudomonas contamination will have a completely different origin. So this is why the real identification of the microbe is very, very important. And then finally, we need to review the production parameters permitting development and survival of the microbe. So we need to look at the milk quality, the heat treatment process. Is it high enough in terms of either thermization or pasteurization? Acidification profile, fast enough, slow enough, whatever the problem. Drainage evolution, aging conditions in terms of temperature mainly, salt level, and residual sugars. You have to remember that the sugars will come from whey, and the high quantity of residual sugar will be directly linked to poor drainage of the cheese. And poor drainage, well, more whey means, well, more water to sell at the price of cheese, which is really good for the cheese making business. But it means also that you have excessive residual sugars in the final cheese this will be perfect food for eventually blue molds that will develop on the surface of the cheese. And then the defects of technological origin, like the slits, the cracks, the moisture, the discoloration defect, those ones, in order to understand more what's going on, we need to analyze both cheese with and without defect in order to be able to compare deviances. Ideally, we need to monitor and record as many parameters as possible when everything is okay, so we can have data to compare. This is the biggest problem that I'm facing with when I'm working with cheesemaker. When I'm consulting with them, is a lot of them say, "Oh, my cheese was better last year." So how was it made last year? If you have the exact idea or the blueprint of the cheese, when everything is good, when it's an award-winning cheese or whatever the quality of the cheese, if you are able to record and save all those data, when you have a problem, it's much faster, quicker to be able to say, well, those 3, 4, 5 points are the ones that are different than what you should have. It's much faster to control and to go back on track. In order to parameters that we would need to look for, we should look for moisture, pH and or Ta for titratable acidity, salt level at unmolding, just after salting, calcium, fat, and eventually when we have bigger problem to understand, free fatty acids, gas production, H2, so dehydrogen, ammonia, CO2, the ratio of volatile amino acids to total nitrogen. This will permit to assess the proteolysis level. We can go very deep in terms of the understanding, like the identification of the free fatty acids will permit to know which type of butyric spore will be involved in the problem due to the specific free fatty acids that they produce and with the quantity of them compared to the other free fatty acids, like the butyric free fatty acid. In terms of technology, we need to differentiate moisture and texture controls. We can see on the left the dry versus moist axis, the vertical axis, and the horizontal one, the chalky versus elastic axis. The texture axis, so the horizontal one, is the position on the axis affects the texture of the cheese, chalky towards elastic, mainly the consequence of acid evolution linked to demineralization. The more minerals, mainly calcium and phosphorus, you can keep in the cheese, the more elastic the paste. Can be linked to the final curd treatment as well, particularly if you make a milled cheese like cheddar. In this case, the cheddaring and the milling process will bring the elastic texture towards a more chalky, but this is more linked to the final treatment, acidification and minerals. Can be linked to also starters, the choice of starter culture, timing, duration, dose of starters, temperature. The faster the acidification profile, the more chance to lose calcium, so the more chance to go chalky. Make a story short. The lack of control will move the cheese on the axis, mainly chalky. Most of the time, the cheese will move towards the chalky side. This is the classic example of the chalky core in the soft cheese, camembert style or brie style. In order to understand what's going on, if you have a texture problem, you should focus on the pH profile, calcium level, and moisture level at various stages. Concerning the moisture axis, the vertical one, the position on the axis affects the paste quality, the aging speed. Of course, the moister the cheese, the faster it ages, but it means also the less control on the aging process you have. It will affect the flavor development, the yield, profitability as well. It is linked to the quantity of water retained and evacuated during production. It's controlled by coagulation process, the works in vat, the drainage parameters in the vat, the acid development in molds, a lower pH at renetting and at molding will directly affect the drainage speeds a more acidic curd will drain faster. This is because the curd being more acidic, it has released more calcium. Therefore, it's more porous. Being more porous, it will be quicker to evacuate the whey out of the cheese. So pH at molding will affect the drainage speed. For that, to control on this moisture, we need to test for moisture, fat, pH, and drainage profile. We've been talking about moisture control and fat. This simple tool in here, the SCIO, it's a spectrophotometer, a pocket molecular sensor. It's a relatively new device, couple of years maximum, and it permits to instantly analyze the fat and moisture and eventually proteins, but not really interesting for us, but mainly fat and moisture. So you can see on the bottom right the scan results. We have the percentage of fat and the water saying 42 grams out of 100 grams, so it means 42%. So this device, not meant to be used commercially, but internally for us, it's a fantastic tool. It permits to have a reading of moisture and fat in few seconds. So we can evaluate the moisture at molding, during drainage, at unmolding, and also the fat at unmolding. Having those major values, fat and moisture, we can easily calculate the MFFB, which is the moisture in fat-free basis, which is the consequence of the drainage level. And the value of the MFFB will impact the aging profile. The higher the MFFB, the faster the aging process, or the less control you have on the aging profile. To calculate the MFFB, you divide the moisture value by 100 minus fat. So MFFB is moisture divided by 100 minus fat. And you can also control and evaluate the fat on dry matter. This will be more a regulation problem in Europe, but also will affect the flavor profile and the texture. Fat is good in cheese. Don't try to make a very high quality cheese without fat. It's not possible. So this tool, this small device, will permit you to know more about what happens during the make. So I would say this device, the pH meter and the thermometer are the three main tools that you should have in your dairy in order to understand what's happening. With this device, we can anticipate what can happen. We can see on the top left, this is a normal cheese, which shows normal in brackets, because I don't really know what is a normal cheese. But this is the more conventional type of product that you have in your aging facility. And when we look at the moisture value and fat, so 33% fat and 39% water, this gives us an MFFB of 58%. Another cheese made that shows kind of a toad skin, kind of the edges that collapse. We can think that the paste just under the rind is more liquid, is more soft, and we see the fat is more or less the same, 32% instead of 33, so very, very close. But the water content is 43 instead of 39. 4 points difference. This gives us an MFFB difference, a value of 63 instead of 58. So the MFFB, the moisture in fat-free basis, is much higher. 5 points is a big, big difference that will affect the aging profile, the texture, the aging speed. The cheese would probably be stronger in flavor, really good flavor, but will go much faster than normal, and the aesthetic will be different. I'm not saying that this cheese won't be good, but it will age faster, differently than what you used to make. Is it a problem for you or not? This defect comes mainly with the moisture, the excessive moisture in the defect cheese, 43 grams at dehooping, unmolding. So this means that the cheese made was too moist. So we need to understand why Why? We have a cheese that was too moist. So we need to concentrate more on the drainage parameters. Was it the fat in the milk? Was it the coagulation process, too much rennet, or the cutting size, the stirring time, the moisture at molding? All those parameters that will affect the evolution and the final composition of the cheese. Remember that the cheese that you make that you unmold, that you analyze at unmolding, the composition of the cheese at this stage is the consequence of what you've done in the vat, well, with the milk and then in the vat. So when we want to understand what happens in whatever the problem, we should analyze the cheese, test the cheese at unmolding, moisture, fat, and pH value, and so on. And we should continue testing after a few days or a few months in order to make the distinction between, is it a problem when I make the cheese, or is it a problem that show up when I age the cheese? Two completely different approach. So we'll start with different questions about. Just take my notes. Gluten. Are all cheese culture gluten-free? Yes, because well, we have to distinguish two different families of cheese culture. We have the lactic acid bacteria and non-starter lactic acid bacteria. So the culture, the starter culture, those ones are lactic acid bacteria, so they grow on lactose. They don't grow on cereals and so on. So they grow in an anaerobic media with sugar, with lactose. So they are grown on a gluten-free media. So those ones, it's clear. It's a little bit, well, it was a little bit unclear with the aging bugs and mainly with the blue molds. The Penicillium roqueforti used to be cultivated on rye bread, the very traditional technique that they are still using sometime in Roquefort industry. So the inoculation of the rye bread loaf. So those loaves of bread, rye bread, are inoculated with blue molds. They are pierced and then stored in the aging environment with the cheese. And when the breads are completely covered with blue molds, they collect the bread, they take the rind out, the crust out, and they mill it and filter it, sieve it, and then after they inoculate the curd. They used to inoculate the curd with the powder made of it. So technically, even if the rye is a very low gluten cereal, this this technique could have some gluten could inoculate the cheese with some gluten. So because of the gluten allergies, this technique now, so most of all the commercial culture for Penicillium roqueforti are grown on a gluten-free media. So they changed completely the media that they used to grow the Penicillium roqueforti in order to avoid this kind of problems. So technically, yes. Another question, some of our feta cheese batches do not set. What would be possible reasons for this happening?
Sorry, Yvonne, sorry, yes. 2,000 litres is the approximate batch size of this company.
So what I don't understand is, what do you mean by do not set? Is it the milk that do not coagulate, or is it the cheese that during the aging process melt completely and make a kind of soup in the bucket, in the storage brine? Because if it's a problem of coagulation after the rennet addition, in this case, it's not linked to the technology. If this is a problem of coagulation, it's not because it is feta, unless you have a pH that is way too low. So if it is a milk problem, you have to look at the pH of the milk at renneting, or TA. A pH that is too low when you add the rennet, the proteins are completely demineralized. the proteins are completely destroyed in a way. So the coagulation will never be possible because the rennet cannot coagulate the proteins because proteins disappeared. So you have to control the pH at renneting. You have to control the temperature. What is the exact temperature at renneting? And the dose of rennet. So far, if everything is okay, it means that there is something really wrong in the milk that you process. If it's a problem with the cheese that melt, that do not keep the shape in the brine, in this case, it's more a question of excessive moisture in the cheese at unmolding. It can be a problem of pH that is either way too acidic, so it becomes too porous, so the moisture goes all over the cheese in. So it can be the pH as well. It can be the brine composition that is not correct in terms of minerals and salt and pH. Be careful with the pH of the brine. Or it can be also the oxygen level that when you fill the buckets with brine, that you still have a layer of oxygen on top between the brine and the lid. And in this case, this oxygen permits the development of some yeast. And this oxygen will permit the development of yeast, and the yeast will send proteolytic enzyme that will destroy the cheese, that will digest the cheese in the vat, in the storage. So I would need a little bit more information about this question to be more precise, but either milk or cheese, two different approach.
So just if the person who put that question in, if you want to give that extra bit of information, do it quickly before we move on. Okay, then I think we just keep going, Yvonne.
If we can have some more information at the end of the
But Emma has just asked there, what would be a too low pH at renneting for a lactic curd, which is kind of similar.
So Emma, you process sheep's milk. So in this case, less than 6.2 would start to be problematic. Less than 6.2.
Okay, thanks.
This would be the one of the control. In a small factory, what are the minimum control points during manufacture to ensure consistency of cheese size? That's a big question. A big question because so the cheese size will be the consequence of few different parameters. The first one to control will be the milk composition. Of course, the milk composition will affect directly the yield. So the higher the proteins and fat in the milk, the more cheese you should make. Or the opposite, the lower the composition, the less cheese you should make. If you make the same quantity of cheese with the composition of milk that change all over the month, all over the year, in this case, don't expect to have standard size cheese. You need to be able to adjust the size, the quantity of cheese made according to composition. And we have some different softwares or slideshow Excel template that can help developing or anticipating this kind of composition. So I can just change this slideshow and show you another one. Do you still see the slides that I have?
No, we've just lost them.
So you don't see my screen now?
No.
Oh, so, okay. Let's do this. And in here?
Yes, we've got it.
So this is an Excel template that permits to anticipate the quantity of cheese. What we need to do is in the green cells in here to fill the composition of milk in terms of fat in grams per liter and not in percentage. Just multiply by 10 instead of 5.02%. This means 50.2% grams per liter. Proteins, volume of milk in here. And then we need to fill in the fat level in the cheese at unmolding, the dry matter, 50%, the number of cheese, and the weight in kilos of cheese at unmolding before salting. Then we click on the button, And this tells us the yield that we should make and the quantity of cheese that we should make according the type of cheese with the targeted dry matter or dry extract. So this kind of this system permits to be able to anticipate this kind of a Excel template permit to anticipate the quantity of cheese that you should make according the quality of the milk. So this is one of the first parameter, right? Then next one, we need to be able to control the moisture level at molding. If at the molding point, some days the cheese is moister, some days the cheese is drier, this will be very complicated at molding. One of the characteristics for the soft cheese production is you have a time for molding that is very short. If we are talking about soft cheese like brie or camembert, this family of cheese, I would say the smaller the batch, the easier to control the standard deviation. That's why even the big factories like, well, I can say Lion in Australia, but also Lactalis all over the world, they all work with small of 400, 500 liters at a time. So when they mold, they use either a tip up or a conveyor belt that mold the whole 500 liters, the whole batch in few seconds. So it means that there is no deviation between the first cheese molded and the last cheese molded, which is very important. So when I see small cheesemakers trying to mold 2000 liters of milk in soft cheese and try to be consistent, if the very big factories cannot make it, well, don't expect to be able to do it with the limited equipment that we can have on an artisan site. So the moisture level at molding and the method of molding will be very, very important to be able to anticipate. So we need to work on milk composition and level of moisture at molding, as well as molding equipment. Multi-molds will be much easier to control the size than individual molds, individual molding. For the hard cheese, big factories, they use a casomatic, which is a pre-pressed column that automatically fill a fixed quantity of curds, or a fixed quantity of curds, and then we can fill one mold with a fixed quantity of curds in. Well, how do big factories reliably produce cheese of X grams every make? And what is their tolerance for variation? The main thing is that the big factories, they standardize completely the milk in fat by skimming or adding cream, in proteins by adding skim milk powder or whey powder, by standardizing the pH with either GDL, gluconodeltalactone, or CO2, carbon dioxide gas injection in the pasteurizer inline, mineral standardization with calcium chloride addition, and then bacteriological standardization with the pasteurization. When we have standardized the milk with all of those parameters, it becomes much easier to use a standardized recipe that will produce a standardized yield and a standardized process. So in this case, it's much easier to have a fixed quantity of fixed size and regular size of cheese, because you know that the milk comes always with the same composition. The tolerance for variation, of course, is as small as possible. In Europe, we have a regulation throughout Europe that is called the estimated weight, that is identified on the packaging with a specific E mentioned. That the 212E for the Unicodes for the name, to find out the exact logo for this. This is an EU requirement, and it's based on the size of the final product that is wrapped. So every product that will be sold wrapped without being touched, if you do not cut and wrap in front of the final buyer. In this case, you must use this kind of estimated weight, and we have a margin of 4.5 grams if the product is between 50 and 100 grams, 4.5% if the product is between 100 and 200 grams, 9 grams if the product is between 200 and 300 grams, and 3% if the product is between 300 and 500 grams, and so on and so on. So there is a table, a fixed table that says if your cheese is within this range of mass, this is the tolerance, the deviation that you can have in plus or minus maximum. Of course, the internal tolerance will be the lowest as possible, because every gram on top of the weight that is mentioned is a wasted gram in terms of money. So a 3% target would be a good target. So it's not about the fixed weight, it's more about a percentage. What is the maximum target waste percentage that larger producers aim for? Well, 0, of course. But we have to distinguish 2 different types of waste. Really the waste that are the consequence of either milk that is left in the pipe, in the truck, in the pasteurizer, in the pumps, all those primary material that you cannot process. The waste of cheese, because technically they are not good, because they are not sellable, because they are contaminated with whatever the problem. The waste, because when you flip the cheese fall over. The waste that the cheese that will be sent for testing, for organoleptic controls, for eating the cheese to see if they are good, not enough, whatever, or the micro internal test. So those wastes are the things, those are the ones that you have to control and to focus on. This is why, of course, the 0 is the target, but obviously it's not possible. But you need to define the different categories of waste. The milk that you buy and the milk that you process, what is the difference in between? The milk that you process and the yield of cheese that you make, well, all at each parameter, you can track the yield and the waste, right? And we have also the weight loss during aging, which is, in this case, is a technological loss. It's a target, it's a targeted waste. We should lose, depending the family of cheese, the type of cheese, we should lose between 5 and 15% weight loss. So in this case, this is also a waste, because this is a weight of cheese, a mass of cheese that disappear during the aging process. But this is a target. Of course, this target should be as low as possible, depending the type of cheese. So each family of cheese will have a specific target for weight loss during aging, which is called freinte in French, F-R-E-I-N-T-E-S, freinte. This is a specific word that describes the weight loss during aging. And we have target. Example, soft cheese, camembert cheese should be 6 to 8%, not more, not less. Less weight loss means that we have a cheese that is too moist, so we'll have problem during aging under the paper in the cold storage. If we have more, we've lost money. So we have a targeted weight loss during aging. So the target waste is as low as possible for the, I would say, the technological waste, milk, yield, cheese that falls on the floor, microbiological test, and so on. This has to be controlled. And the weight loss, the freinte, you need to control them, you need to measure them. And this will be mainly the consequence of your cheese aging equipment. It can be a big, big sum of money at the end of the year if your aging equipment is not correct. That's why most of the factories, they use a control card. A control card is for each parameter or criterion that you want to assess. It can be, example, the difference between the milk that you buy and the milk that you process in terms of volumes, liters, weight, or whatever. It can so we use if we talk about this criterion, we can use a control card that says you have a green zone, you have an orange zone on top and bottom, and then you have a red zone again on top or on the bottom. So your target is to be in the green zone. Then when you enter the orange zone, there is a warning, something that has to be done, to focus on, to control. And then when you are in the red zone, this is where you really have to change the parameters. Something's going really wrong. So you can use this system of control cards with every kind of parameters that you want, with the pH at molding, with the moisture value at unmolding, whatever the criterion. Try to look with this kind of control card, green, orange, red. Up to you to define the what are the limits for each zone. But this is a visual system that helps you to understand what are the different parameters that I am in control with, and the ones that I'm losing control. So this is very important, because if you measure the value of pH, let's say at molding being 6.15, is it good or not? Is it in the green zone, in the orange zone, or in the red zone? If you just read the value, just a number for the number, it's not useful for you to understand where you have to work on, where you have to be more precise, right? I heard some people say Chimax rennet cause bitterness in the cheese. Oh. What are the benefits of using alternative non-animal rennet? Just started making a raw milk cooked curd with non-animal rennet. Can't wait to taste it. A few points. Chimax is a fermentative rennet, coagulant, that's made with, I forgot if it's Aspergillus niger or Rhizomucor mieri. So it's a fungi, either a yeast or a mold, that we put in a fermenter that with some food, with great conditions, a lot of sun, sandy beaches, and so on. So this bug is very happy and releases a lot of curdling enzymes, some enzymes in the environment that will be collected after, filtered, cleaned, and so on, and concentrated. And we use this coagulant to coagulate the milk. It has a very, very similar behavior than the rennet, which is the animal extract. Little bit, less expensive, usually longer shelf life, and stronger activity. So it means that we have to use less. So in terms of storage, cost, and so on, it's interesting. The main thing for this kind, for me, the main interest in artisan cheese industry of this non-animal rennet is that we can open the vegetarian market. That's for me the only interest of it. To open a specific market for veggies. There is no direct relationship with Chimax rennet and bitterness. Bitterness is the consequence of bitter peptides production. Can be some amino acids as well, but mainly bitter peptides accumulation in the cheese. Those bitter peptides can be produced by coagulants. So animal rennet can create bitterness as well, but Chimax, Maxirene, Chemostar, and so on, all those rennets, if you use, all those coagulants, if you use too much, you will have a dominant primary proteolysis that degrades proteins into peptides. So you may accumulate bitter peptides. If those bitter peptides are degraded by peptidase enzyme that degrades the peptides into amino acids, the bitterness disappears. So it's not only a question of the type of rennet. It can be the starter culture, it can be the quantity of calcium, it can be the temperature, the cooking stage, the drainage profile. There are many parameters that can impact bitterness in cheese. So not only Chimax. You have to be careful on not using too much. So this would be the main control that I would suggest. Be careful of the coagulation speeds and the strength of it. Benefits of using alternative non-animal rennet only for veggie market. Well, to develop veggie market for artisan cheese industry. In big factories, this can have an impact, a significant financial impact, because technically the non-animal rennet will show a slightly higher yield and a cheaper cost. So we can save a lot of money by using non-animal rennet, those kind of coagulants. But it will start to be significant with bigger factories, something like 10,000 liters a day will start to be significant. And well, for me, just started making raw milk cooked curd with non-animal rennet. For me, this is a syllogism. We try to make a very artisan type of cheese, so raw milk cooked curd, with a very industrial process, which is the non-animal rennet. So I don't see the points of it, I would say. It means that you are trying to be seated within two chairs, so either start to be really artisan and ideally make it with animal rennet. If it's a veggie market problem, in this case it's different, but I have some, my old friend Randolph Hodgson, which is the founder and the co-owner of Neal's Yard Dairy in London. He is able to detect animal rennet and vegetarian coagulant in a cheddar cheese when the cheese is old enough. But I would say a very, very small percentage of the population is able to find the difference. So in terms of flavor profile, well, it's a question of ethos, the way that you want to make the cheese. If you want to make a raw non-cooked, well, or cooked curd, means that you are looking for a traditional technique, way of making cheese and so on. So maybe if vegetarian market is not a problem for you, maybe you should look for a more animal rennet. Don't forget that in the animal rennet, we don't have only the coagulant. We also have other enzymes, amino acids, peptides that will contribute to the quality of the cheese during the aging process, particularly if you look for a high quality rennet. Well, we can talk about this kind of a subject for hours. Ups and downs of having our own seasonal milk herd. Other than skimming, how can one adjust the milk to account for increased fat and proteins? Cow's milk due to calving and late lactation. Particularly for wash rind, what are the potential effects of the increased fat content in hard cheese, alpine and cheddar flavor profile as it ages? So we have to consider a few things. The seasonality of the milk will directly affect the quantity of solids. One of the main parameters is that the high solids in the milk will affect two different parameters. The first one is the acidification profile. Very high proteins will create a higher buffer power, so will show a delay in the acidification profile. This means you're with the normal quantity of starter culture, normal temperature and so on, but with the higher solids, the pH drop will show a significant delay. So you will have to wait in order to be able to measure a pH drop. This can have significant consequence on the make day if you work with the target pH, and with the quality of the cheese. If you work by the clock and not by the acid level or the pH level, in this case you will be molding with the higher pH or lower pH depending the season. So this will have impact on the composition of the cheese at the end, in good or bad, right? So if you have a high proteins milk, you have a higher buffer power. So either you have to wait more before adding the rennet and processing the milk, or you have to increase the dosage of starter culture in order to be able to compensate this delay in the acidification profile. The other thing that is important is in the high solids milk, we have, well, less water, more solids. So we have to decrease the drainage parameter. Otherwise, the curd at molding and the cheese at unmolding will be too dry. When the milk is much, if we use the same drainage, the same recipe, the same drainage parameters, the cheese will be too moist. So you have to adjust your drainage parameters according to the richness of the milk. High solids in milk means less water, means less drainage parameters. Lower solids means more drainage. potential effects of the increased fat content in the hard cheese. So the fat in the hard cheese is detrimental to the drainage level. This high fat milk will show a poor drainage level in the cheese. So you will end up with a cheese with a higher MFFB, moisture in fat-free basis. A higher MFFB will mean a faster aging profile. Faster aging profile in the hard cheese is not desired, because most of the time this leads to wild flavor. So you lose the control of the aging profile. And one of the classic or main consequence is we start to have some hitchy, spiky, spicy sensation in the back of the mouth, on the throat, the top of the throat. And this is often linked to the quantity of a histamine. Histamine is an amine biogen that is the consequence of amino acids degradation. And this accumulation of histamine is directly linked to the aging speed. The faster you go, the more you lose control, the more histamine you may accumulate in the cheese, so the more off flavor you will have. Protein and fat ratio of our summer milk is the ideal ratio for us. Yes, this is usually the period of the year when we have the lowest fat and proteins ratio. In here you write proteins divided by fat. In France, we use the opposite. We use fat divided by proteins. Well, you drive on the wrong side of the road as well, so this is a different story. But the proteins on fat ratio, or fat on proteins ratio, is linked to the type of cheese that you should make. Ideally, the drier the cheese, so the longer the aging profile, the smaller should be the ratio. It means that you should have less fat according to proteins. The more soft cheese, like you are talking about, the wash rind soft cheese, in this case, we should be looking for a higher fat divided by proteins ratio, so more fat compared to proteins, in order to keep this richness, oozy softness of the paste. So technically, talking about precise value, a soft wash rind cheese, we can look for a fat divided by proteins at about 1.35 fat divided by proteins, while a hard cooked cheese, like an Alpine style, that we want to age for 8, 10, 12 months, we should be looking for a ratio of fat divided by proteins of about 1.15 to 1.20 as a starting point.
Okay, so we're meant to only have another 5 minutes. We're probably going to run over time, so I hope you're all able to stay with us. Please continue, Ivan.
Just try to go faster. Perfect environment. Ivan's recommended affinage process for Alpine style cheese from post brine onwards. Well, first of all, I would not recommend brining for Alpine cheese. I would recommend dry salting, because using dry salt for 2 to 3 weeks, depending the size of the cheese, of course. But if you spray dry salt and rub it up, this permits, well, to salt the cheese, but also to create the rinds fast with the salt. So this dries out just the top layer of the rind, and this permits to start sealing the cheese. So this will limit the weight loss during aging, right? And it will create a better rind. So if you look at the AOP cheese like Gruyère, Beaufort, Comté, Abondance, all of them are dry salted for a longer time. It can be just 3-4 days or up to 3 weeks for a 40 kilos cheese. So every day, every other day, we put some salt on top, we rub it up and leave it. But after that, this whatever the salting method that you use, technically we should have a pre-aging room that is warmer and kind of humid, warmer being something like 15-16 degrees Celsius, and high humidity content, about 92, 94% hygrometry. This permits to terminate the secondary fermentations and to get rid of the lactates, citrates, all those materials that can be food for the NS labs or spore forming bacteria or bugs that will eventually create gas blowing, cracks, slits of flavors in the cheese. So you need to keep the cheese in a kind of a warmer environment first to finish the degradation of those residual sugars and lactates, citrates, and acetates as much as possible. So as an example for the Comté, the cheese kept 3, 4, 5 weeks at 15, 16 degrees Celsius before being sent to a colder environment. So the aging profile, so we can say that we have aging 1 at 15, 16 degrees C at 92, 94% humidity. And then after that, we have the rest of the aging process at 10 degrees Celsius and 96% humidity. Usually the rind is just done by brushing or washing the cheese with just salted water or dry brush. So just trust either what you have in the milk or what you have in your aging environment. You have to remember that after 4 or 5 months, the living things that are on the rind of a cheese are not the bugs that you added into the milk at the beginning. So most of them are dead by now. And after 4 months, what you can find alive on the cheese is what you have in your environment on the salt, on the water, in the cellars, in the cave that you have. So this means that you develop your own flavor profile. So personally, I would just use salted water, 3 to 5% water, depending if you have Pseudomonas problems. If you have pseudo problem, you can start with the very salty brine because pseudo doesn't like salt. And then the more you go in the aging process, the lower the brine concentration. But usually on the normal process, 3 to 5% brine. Wash the cheese, top and sides, and never wash the bottom, the side of the cheese that is in contact with the aging materials like the wood or rags. You will wash, you turn the cheese first and then you wash it. And the cheese tells you when it's time to wash by touching the rind. If the rind is still kind of humid and wet, don't wash it. If the rind is feeling dry, it needs washing. So the cheese tells you if they need washing or not. Amount of time in brine affect the flavor profile of Alpine style. The brining time will affect the quantity of salt in the cheese eventually, even if this family of cheese is very dry. So the salt intake will be limited. So it's the quantity of salt that will affect the flavor profile because the quantity of salt will modify the enzymatic reaction and the way that the bacteria, yeast, and molds are able to develop in the cheese. It's not the brine, it's not the salt itself that modify the flavor. So will lower salt content result in sweeter flavor? No. The sweet, the aromatic profile that we may have in Alpine cheese or others is the consequence of the peptides and amino acid production that are more savory or sweeter or nuttier or more vanilla or more meaty, whatever the family of flavors. This is the consequence of the aging profile, the proteolytic activity, lipolytic activity. The quantity of salt affects only the speed of the proteolytic activity and lipolytic activity, but it doesn't affect the final type of flavor that you will have. So higher salt is not more savory, right? Because a Comté is not a very salty cheese, but it's it can be very meaty and savory and brothy, or sweet or nutty. So it's not linked to the quantity of salt. So the adjustment of sweetness will be easier by NS labs, so what you call either propionics or adjunct. Propionics or adjunct culture usually can be classified as NS labs or props as well for a specific family of propionics. If you look really for sweet, you should focus on propionics. Some that produce gas or not. There is hundreds of different range of strains of propionics. Adjuncts will have some NS labs, non-starter lactic acid bacteria that can orient the aging profile of your cheese towards a sweeter, nuttier flavor, but don't play with the brine to adjust the flavor profile of your cheese. We like even to confirm percentage moisture of our MFFB at hooping. So one point, we never check the MFFB at hooping. We check it at unmolding, unhooping. We check the moisture eventually at hooping. So there is probably a misunderstanding in here that noted 55 at the recent workshop, a 55% MFFB. If you look at the bottom version of different values for blue, 55% at MFFB is a very, very low MFFB only for very dry cheese. So it's probably 55, that would probably be the dry matter and not the moisture. Well, that's probably a confusion in the values. This is, you have two different things. With the SCIO equipment, you can measure the moisture level at molding. So 55% moisture level at molding, that's achievable. 45% dry matter, that's not very achieve, but that depends really the type of blue. You're talking about blue. Blue is not one type of cheese. You can take every kind of cheese and put some blue molds in, and you will have a blue cheese. So technically, it's not a fixed family. So you cannot have just one value for one family of cheese. So with the SCIO, you need to control the moisture level at molding, and then you check it again at unmolding, and with this value at unmolding, you can extract the MFFB. Though in the bottom in here, you can see different values for different type of cheese. Of course, those values are references and starting point. Well, depending the type of milk, the type of cheese that you want to make, but this is more or less where you should be. Right? So first check moisture at molding, and then moisture and fat at unmolding. MFFB at molding is at hooping is irrelevant.
So Emma says there that she's talking Roquefort style. So
Roquefort, we should be MFFB at unmolding at 65%.
Yeah. Okay. Great. Okay. So thank you very much there, Yvonne. We've had a follow-up on the feta. So the texture when it comes out of the hot room the day after making is soft. It then dissolves in the brine and is slimy when packed.
So this is a problem after the make. It's not a problem in the milk, it's a problem after the make. Okay, so this is a problem with with the composition of the cheese when you put into the brine. So it can be the salting method. Usually the feta must be made first, then salted, dry salted. Then when it is dry salted, we have to store it in the final brine, but don't use the storage brine for the salting of the cheese. This is a common mistake that cheesemakers do in order to shortcut the process. But the brine in this case is too weak in salt, so it leads to problems in the final cheese.
Very good. Okay. Has anybody else got any other questions they'd like to type in? So this is your chance, big chance. Here we go. Debbie's got one there. Can you read it out, Yvonne?
Yes, editors on posting hard cheese to the UK. No, because this has to be shipped, well, it EU. So it has to be through, ideally, the easiest way would be through a broker that would organize all the custom thing. It's exactly the same as shipping cheese, raw milk cheese in here to Australia. You have to face all those admin paperwork with the cheese analysis, the batch papers, and all of that.
Very good. Okay, and there's a thank you there from Grace. So I hope Yvonne has been able to help you all today. I'm really appreciative of all the people who sent through their questions. And Yvonne, thank you so much for getting up so very early to help Australian
No
cheese
worries.
makers. It's absolutely fantastic.
Just watching the snow falling down out, and it's still -4, but it's okay.
Gosh. Okay. Okay then.
Thank you very much, everybody, and well, speak soon.
Yeah. Okay then, and thanks once again to everyone who handed their questions in.
Thanks, Luke. Thanks, Debbie.
Okay then,
Thanks,
and
Alison.
we'll do our follow-up meeting now.
Thanks, guys.